Section 2.4, Deductive Reasoning. So unlike inductive reasoning, which uses examples to make a conjecture, deductive reasoning uses facts, rules, definitions, properties, and different laws of logic to make conclusions. We're going to go through two laws of logic that are building blocks of deductive reasoning. The first law we'll discuss is called the law of detachment. This law is also called modus ponens, from the Latin, the way that affirms by affirming. Here's how it works. If you have a statement P implies Q, then P is asserted to be true. We conclude that Q must also be true, right? So if the statement is true, then the hypothesis is validated, the conclusion must follow. In symbols, we would say P implies Q and P implies Q. So an example, if today is Tuesday, then John will go to work. So that's a conditional statement. Then we learn that today is indeed Tuesday. So the hypothesis is satisfied. We can therefore conclude that John will go to work. Right? The conclusion must then be true. This law balances on the two premises. Right? If the conditional statement is true, which it may or may not be, and then the hypothesis must also be true. So those are the premises, the first two statements. The conclusion is only valid if those premises are true. So here's another example. If a cat purrs, then it's happy. Now, that may or may not be true. Let's assume that it's true. Then we learn that Fluffy over here is purring. According to the law of logic, or the law of detachment, we can conclude that Fluffy is happy. That is indeed a valid argument by the law of detachment. If we turn this around a bit, now we see if a cat purrs, then it's happy. We're assuming that that is true. Then we learn that Tabby over here is happy. A common mistake would be to conclude that Tabby is purring. And that is wrong. That is an invalid argument. That's called the converse error. Right? In the second line, we see Tabby is happy. That's the conclusion of the conditional statement. We cannot make that valid argument. That is an invalid conclusion. Next, if a cat purrs, then it's happy. Grumpy here is not purring. Can we conclude that Grumpy is not happy? Again, this is a perversion of the law of detachment. This is not valid. This is called the inverse error. We can't make that argument. One more example, and this is kind of a silly example. Let's say everyone who eats carrots is a quarterback, which we can rewrite as an if-then. If you eat carrots, then you're a quarterback. John eats carrots. Therefore, we can conclude that John is a quarterback. Now, this is a valid argument. Right? We set up an if-then statement. The if part, the hypothesis was satisfied. We can then conclude that the conclusion must also be true. Even though it's logically valid, the false premises make it a not sound argument. Everyone who eats carrots is a quarterback. Well, that's ridiculous. So even though it's a logical argument, it doesn't make a ton of sense. Another couple of examples. Here we have a series of if-then statements. If an animal is a dog, it has 4 legs. If an animal is a bird, it has 2. If an animal is a spider, then it has 8 legs. Let's assume that these 3 statements, these premises, are true. Let's say we learn that Bjorn is a spider. We can therefore conclude Bjorn has 8 legs. That's the law of detachment. We've satisfied the hypothesis with the conclusion. Let's try another. What if we learn that Sam is a seal? Well, according to our if-then statements, our premises, we have no information about a seal. there's nothing we can say about Sam. Last example, let's say Pat has 4 legs. Again, this is that converse error. We're switching it around. We can't make a conclusion that Pat is a dog. That's invalid. For all we know, Pat's a chair. That is not a conclusion that is valid. We can't say that Pat is a dog. The if part of the sentence must be satisfied in order to make the conclusion for the then. The second law of logic is called the law of syllogism. This law takes 2 or more conditional statements and forms a conclusion by combining them, by combining the hypothesis of one statement with the conclusion of another statement. In symbols, we see if P implies Q and Q implies R, then P implies R. It's sort of a way of condensing many conditional statements into one. An example, if Maria is sick, then she'll be absent. If Maria is absent, then she will miss her classwork. According to the law of syllogism, we can condense these 2 statements into one statement. We would conclude, if Maria is sick, then she will miss her classwork. That is the law of syllogism. Right? It strings together many conditional statements. Here's kind of a fun example for you. If it's a sunny day, then I will play outside. Let's assume that's true. Let's also assume that if I play outside, then I will lose track of time. Well, if I lose track of time, then I will stay out too long. And if I stay out too long, then I'll get sunburned. And if I get sunburned, then I will look goofy in my homecoming pictures. According to the law of syllogism, our final conclusion strings together the first and the fifth all throughout these sentences into, if it's a sunny day, then I will look goofy in my prom or homecoming pictures. Now I realize that this is a ridiculous statement, but it's a valid argument. If we assume that these premises, these 5 statements, are true, then these premises lead to this conclusion. It is logical that if it's a sunny day, I will look goofy in my homecoming pictures. By the way, I kind of did look goofy in my homecoming pictures.